Hello and welcome back to the lecture on applied econometrics, and we are talking about hypothesis testing. Now, we have been talking about the decision rule for inferencing to do statistical inferences, and we said that we need to be familiar with some concepts to actually understand how we can actually do the inferencing. And we talked about several concepts like level of significance, we talked about confidence level, confidence interval, p-values, power and so forth. So, in this lecture we are going to sort of talk in detail about p-value, and you will notice that whenever you talk about statistical inferencing, this concept p-value comes pretty frequently, and we often say that p-value is so and so, so I decide to do so and so, like I take so and so decision. We often do that. We often do it mechanically. But there is a very interesting intuitive reasoning or logic how we see the p-values and why it matters. And in this lecture we are going to see the what the p-value is, as well as why we actually use something like a p-value, and we will also do some sort of small hands-on to actually see how we can derive the p-value. So, let's start. Now, let's say I can define p-value as, we call it the strength of evidence against the null hypothesis. I repeat, p-value is the strength of evidence against the null hypothesis. And we will see the way we sort of use p-value is, let us say I have a distribution here. It's a very bad normal curve I have drawn. So, let us say I have a distribution here, and for this distribution let us say I have this level of significance alpha here, and I have a p-value. Let us say this is the p-value here, I obtain the p-value, and depending on my z I will have my p-value. And if I have a very small p-value here, let us say this is the this is the CDF, cumulative density function, we will just talk about it for z. And if the p-value is very small, then we say that we reject the null hypothesis. Okay. So, again going back to the wordings, we have strength of evidence against the null hypothesis. So, for a very low p-value, or I will write down here, for a very low p-value we reject the null. Okay. And for a high p-value, let us say my p-value is here, I will use a different color, let us say my p-value is, my z is here. So, the p-value would be this much, the whole area under this curve, and then I will say so this is the, so I will use the yellow color here if the p-value is high. So, I will say do not reject null. That is how we sort of use the p-value in taking the decision, right. So, I just this is a mechanical part of the p-value, okay, how we use it usually, but we need to actually understand where from it has come. But before I go there, I will also explain this difference between p-value and level of significance. P-value and say alpha or level of significance. So, they are not the same. Sometimes people confuse. The alpha, as you have seen, it is a predetermined thing. It is a predetermined thing. Alpha we have already decided. So, it is a 5%, it is a 1% alpha, whatever level we sort of want to, whatever level of type 1 error we want to allow, completely based upon the researcher's judgment. The alpha could be chosen 5%, 1%, 10%, whatever that is. Whereas, the p-value that is obtained from the data, the researcher does not have any prior about the p-value that he may get. It is just completely based on the estimation from the data. So, as long as his so essentially it is this alpha. So, as long as the p-value is less than alpha, if it is a right tail test, or p-value is greater than alpha if it is a left tail test. So, we can basically say that we reject the null hypothesis. So, we use both the p value and alpha to actually take a decision. So, let us say if we have a 5% level of alpha, which means this and for a two-tailed test, which means this for a 5% level for a two-tailed test, the value of alpha is going to be 2.5%. And if let us say we have a standard normal distribution, so where x follows normal distribution 0, 1. So, what we will have, we reject the null, reject null. So, basically if my z is either here or the z is either there, right. So, we will say reject null if z is greater than 1.96. So, this is the value we have for this area, right. This is standard deviation, the sigma is 1 and 1.96 sigma, right, both side. So, if z is greater than 1.96 sigma, so that means if z is here, we basically reject. We also reject if z is less than minus of 1.96, right. So, essentially if z goes in this side. So, in both the cases we reject the null hypothesis. Essentially that is how we use p value and level of significance to take a decision. Now we come to the y part. Basically how we are actually coming to this understanding, how come we are using a tool like p value and how come we are coming to this decision if p is more than alpha or less than alpha, we sort of take a decision if we take a call. So, to do that, to understand that, we have to basically see the definition of a p value, and p value is basically it measures the area under the curve for, I will write down, it is a probability that the z statistic is, the value of the z statistic is more than the test statistic given that h naught is true. So, what I mean, I will explain, and that essentially would mean the CDF of the test statistic. Okay. So, in this particular case, this is for the right tail test. What I mean, essentially if you see again, if we go back to the previous diagram. So, if the value of the z statistic is more than the test statistic, okay. So, if the value is for a given h naught, when the h naught is true, I am basically whatever is the test statistic, whatever, so if the test statistic is here, the value that I get, this cumulative density function, if we just sum it up, basically the area under the curve, so that will represent the p value. So, here my test statistic is z. So, z is nothing but x minus mu by sigma. So, essentially whatever the value of z I get, so the area right to this is the p value. Okay. And this is specific, that is why I have written that it is for the right tail test. Okay. And so, the right tail test. So, when I am assuming h naught is true, okay. So, I am assuming it is a true sort of distribution, the sample is actually drawn from the true population, and then only I can actually sort of, with this assumption I estimate this area under this curve, right, and the area under the curve is basically it gives me the p value, whereas for a left tail test it will be 1 minus CDF for the test statistic. Okay. So, it is quite obvious. For a left tail test, what we will do? We will basically measure the area this side. All right. So, basically you have to understand that what is happening here is that again the p value is actually measuring the extent from the actually true z we observe from the population or the sample, the z statistic that we get, and it is simply checking where the z statistic is lying. So, depending on the position of the z statistic, we are calculating the p value. It is as simple as that. So, the whole area under the curve is representing the all possible possibilities where the z can lie, and p value is actually representing the area under the curve depending on where the z is actually lying. Okay. So, that is what the p value is, and it is quite obvious because if the p value is here, so that is basically it means the z statistic is lying pretty extreme from the population parameter, and when it is lying pretty extreme to the population parameter, we want to actually say that the sample is perhaps not representing the population, right. So, we reject the null hypothesis. So, that is basically the idea of p-value. All right. So, with this we will actually do one example, just one example of p-value, and let us say this example is about, let us say, social media usage, okay, social media usage. Let us say social media usage of for the students in IIT Kharagpur, and let us say we have national average, let us say population mean. So, let us say people usually use around 30 minutes per day, they use social media, okay. And let us say, so my alternative hypothesis is that the social media usage is, let us say, more than 30 minutes. So, if I want to see if the students in IIT Kharagpur actually they use social media more than 30 minutes a day. And what I observe when I actually collect the data, I observe the test statistic of x bar. For IIT Kharagpur, I see that it is actually 40 minutes, okay. And let us say we have given sigma is 20 and my number of observation is 25. So, I have taken data from 25 individuals and I found that the actually average is 40 minutes. So, now I have to sort of decide whether I can reject the null hypothesis that the population mean is higher than the null hypothesis population mean is equal to 30 minute. Sorry, the mean usage of social media usage is 30 minute. Okay. So, to do that, what I need to do first, I need to have my Z statistic. My Z statistic is going to be x minus mu by sigma, which is x minus mu, and by sigma is 20 by root n, that is 25. So, that means 10 by 20 by 5. So, that is 2.5. Okay. Now, for a Z of 2.5 for a one-tail test, we have the value. So, essentially I have to get the p-value, and p-value is nothing but I will use a different color. So, the p-value is going to be the CDF that Z is more than 2.5. So, if Z is more than 2.5, so remember the distribution, if Z is more than 2.5 here, so I am going to get this area. So, I have to see if this area is falling right or left to the level of confidence, all right. So, if I actually get this number from Z table, standard Z table, we can actually see that. So, this is what we will get 0062. Now, 0062 is much less than a 5% significance level or 1% significance level. So, essentially we reject the null hypothesis. So, essentially we mean the students, what we can conclude, the students in IIT Kharagpur are actually spending more time on social media than the population, So, that is basically the concept of p-value, and that is basically one application of p-value, but going forward we are going to see many usage of p-value, and it will be always important to sort of remember where from the p-value has come, how the concept behind deriving p-value, instead of just mechanically kind of saying that p-value is less than so and so, so I reject the null. We can actually do a better job with p-value. So, with this we end this lecture here, and going forward we are going to talk some other concepts about hypothesis testing.